marking, it sees the road is turning, correct, bending, correct. If it is seen by the autonomous vehicle, which way it should become master? Bus master, steering control, correct. When steering control, automatically vehicle speed should be reduced. Steering control does not what is vehicle speed. Who knows vehicle speed? Engine controller, correct. And if needed, brake has to be applied. So that time, that ECU will become bus master, others will listen. Okay, we'll see how during that time the steering will become bus master. When you are applying brake, ABS will become bus master. Well, you want to accelerate, correct? During the time, engine ECU will become a master. Others should just remain. So that is possible in case of CAN bus. Right now, you understand that. That we'll see how it happens later. Okay. Yeah, that means any node can send this one message. That's why it is called multi-master. CAN bus is called a multi-master bus, and all nodes will receive and act as a what you call a slaves, which is called a message multicasting. Receiving is called multicasting. Sending data and received by multiple devices is called multicasting. Then you can transmit data from 125 kilobits per second to 1 megabits per second in CAN 2.0. CAN 2.0 is very old. This one, the new CAN 2.0B is come, correct. The new version of CAN is coming. Original CAN bus, which was invented some 1986, correct. It was CAN called 2.0 original version, where the low speed is 128 kilobits, maximum 1 megabits per second. Please see that RS-232, how much was that? 19.6 kbps or 36 something, maximum 36 kbps. Dead slow. You can 1 megabit 1000 mpbs, correct? Kbps, correct. The lowest speed is 125. Here it is only 36. So RS-232 cannot be used for high-speed communication, for safety related, like connecting engine ECU with brake and steering, all those things. They have to act in millisecond like that. So you cannot use RS-232. So we have to. That's why the CAN bus was invented. Okay. Apart from that, the CAN bus sends data to what you call as a messages. Data is sent as messages, right? So message, you can have 2048 different messages. In CAN bus, you can have 2048 different messages. Okay. BOS CAN specification became ISO standard. Right? BOS is called as CAN bus, but when it become international, they give into ISO number. Right? So if you say ISO 11892, it is nothing but it is a CAN bus. That means it is a CAN bus. BOS calls a CAN, ISO called ISO 11890. That is number given. Okay. I told you there are many versions. The initial version, which was supported in 1993 by ISO, is CAN 2.0A. This is called by Bosch. Bosch calls as CAN 2.0A, which was into 1993. But ISO number is same. Both are same only. That's what I want to say. Right? Then they released the next version, which is called CAN 2.0B. CAN 2.0 is the old version. 1995, they introduced the next version, CAN 2.0. Now, the latest version is called CAN FD. You can see here. FD means flexible data rate. It was introduced in 2012. It is called CAN FD. Okay. This is the latest version, introduced some 10 years before. Right? Almost 10 years before. Here, the maximum data speed is 8 megabits per second. Please see here. Here it was 1 Mbps. These two, CAN 2.0 and this one work to this one. CAN FD, which is latest, can go up to 8 megabits per second. And it allows data transmitted 64 bytes. In CAN 2.0 and 2.0, you can transmit 8 bytes of data in one message. In one message, you can transmit 8 bytes. What happened in RS-232?
7.
No. 1 byte
One
only.
7 bit data.
One byte only. You can transfer 1 byte at one start bit, 8-bit data, 8 or 7-bit. Basically, you can say 8-bit, 1 byte at a time. But in case of CAN bus, you can transmit 8 bytes, not bits.
Got it, sir. Got it. Sorry.
Right? So this is called as one message or packet. Generally, they call CAN, they call it a packet. Sometimes colloquially, they call it a packet. One packet means 8 bytes. 1, 2, 3. Each one has 8-bit data. So 8 bytes pack. Then there's a start byte. Correct? There's a end byte. And there are error correction. All this we are going to see. Okay? So you can, minimum 8, you can maximum 8 bytes you can transmit. Minimum is the 1 byte. Right? You can pack 1 byte, 2 byte, 3 byte, up to 8 bytes. In case of CAN 2.0 and 2.0. This is very old. Please note that a vehicle, correct? Which bought, suppose you bought a vehicle 10 years before, or old design, CAN bus. You maybe you know maybe using, correct? And I told you, one they make a hardware, correct? ECU is a CAN bus controller, their ICs are needed. That the minimum 10 years they use, because the design itself take a tedious process, 5-year design, maturing all these things. They don't throw it. If that is the speed is sufficient, they leave it. Even latest vehicle they may use CAN 2.D or 2.A also, old vehicles. Okay. In case of new vehicles, they're trying to use CAN FD, where you can go to 8 this one. But in CAN FD, you can pack up to 64 bytes. Newer version, if you want to use CAN FD 1.0, you can pack up to 64 bytes in one data packet or one message. Okay. The CAN bus interconnect network modules, which are also called nodes. I told you, this is called network modules or nodes. Using 2-wire and twisted pair wire. Right? Clear, just like your RS-232, it needs only 2 wires. It doesn't need 4 wires like SPI. Here it needs only 2 wires. One more thing also, the wires cannot be straight wires. The wires cannot be 2 straight wires. Right? Generally, the wire will be twisted. It will be twisted. Take 2 wires, twist it. Like ladies with a pigtail, you know, they take the hair and make it a pigtail, ponytail. Correct? So pigtail means the twisting. So the wires will be twisted. The twisting helps in reducing EMI noise, no doubt. By twisting wire, like you can see that. Correct? Twisting is not one with this one. Like take 2 wires. Just like this, I told you, the twist wire. So then it reduces electromagnetic interference. If I have the straight wires, it can pick electro EMI. This is straight wires. Correct? I see the one wire going like this. Another. This is one node. This is node A and sent to node B. Correct? This wire is, for example, 10-meter length. Wires are not twisted. Then it can pick EMI noise from spark plug. Correct? Or from a telephone signal, cell phone signal I'm talking, telephone or TV signal, all these things will be picked by this wire and they may corrupt your data. EMI can corrupt data, already told you. Spark plug can give this one, and the device, you are sending data 1010, 1101, correct? This bit become 1. So this is this is due to noise, EMI noise. If I use straight wires, it can pick this one. By twisting wire, you can reduce EMI noise picked by the wires. Which wire? CAN bus wires. That's why they are twisted. If
so what is the physics behind this?
Pardon?
So what is the physics behind this?
Yeah, that's what I'm right. You read here.
Oh, okay.
The bulleted points. That's why the picture also shown here. You see that this is one wire, this is another wire. Okay, they are separated by maybe less than 5 mm. Correct. This is a big sheet. Correct. Inside that there are 2 wires are going. You take a power cable. Correct. There are red color, yellow color, green color, 3 wire. One is phase, neutral, ground. Correct. All this thing inside one big sheet. Correct. Now this is a electromagnetic source, EMI source. Correct. From here, the electromagnetic radio waves are coming. That's what is shown. Please note down. This is nothing but the electromagnetic noise coming from a spark plug. Correct. This wire, this is very close. The source. The distance is very small. The second wire is little away. Please note that it may be few mm only, but this will pick more voltage because the wire closer to the electromagnetic source will pick more voltage compared to this. So already you are transmitting data, correct? This is my ground wire. This is my signal wire. So this will add my signal, parallel wire. Now, if I twist it, what happens if I twist like this, right? It picks and it will be cancelled. If I twist it, the electromagnetic voltage, here it is picking noise, correct? This wire is not picking, correct? This is also picking less noise. This is less noise. In this part, this is closer. This is my electromagnetic source. This wire pick more noise. This is less noise, this wire. But now this wire come here. So this picks more noise, this picks less noise. So what will happen? It will cancel out. But if you twist it, the electromagnetic noise picked by wire will automatically cancel out. That is the principle behind this. That's what I explained here. We have found it because these are the practical experience. Somebody has worked day and night how to avoid all this EMI noise, this one. Okay. So that's why I put this picture also for you to understand. Twisted pair, because here it picks more noise, this is less noise. By the time next within 1 inch, because twisting is not every feet. You will twist, if you see the wire, CAN cable, every 2-3 inches will be twisted. Correct? So that means it automatically just cancelled out. That's why shown here. It hits here, hits here, hits here, hits here. So automatically get cancelled. Okay. Okay. So this is one. I will give a break.
Okay, sir.
Yes, sir. 5 minutes, sir.
Thank you, sir.
Yeah, sure.
Sir, we can start, sir. Sir, we can start, sir. Can you hear me, sir? Hello, sir.
Yeah.
Can you hear me, sir? Yeah, we can start, sir.
Okay. Thank you. Okay. So in CAN, I told you there are two things. Still, this is a old version number 2.0A. We are talking about after accepted by ISO. Okay. 2.0 is that's a very old, 20 years old. That is 10 to 20 years old. So where it uses 11-bit identifier, correct? The identifier means so many 2 power 11 different messages can be sent. The identifier is a 11-bit identifier. It can value, that means it uses 11 bits. Right? It become 111. Okay. So that means 0 to 2048, 47. Totally 2048 different messages. In CAN bus, each message will be given with an ID. No doubt. CAN message should have an ID. Will have an ID, not should. Will have an ID. Okay. That value can be 0 to 2047. Okay. You may, I will, so for example, you take your engine ECU. Engine speed. What are the important parameters engine ECU? Engine speed, correct? Engine power, engine torque. Okay. I say that ID number 0, correct? ID number 0 is engine speed. This ID will hold engine speed value. ID 0 means if any device sees ID 0, the data will be transmitted in like a start bit. Please note that like a start bit, the ID also will be important. We are going to see that. Start bit will be there. After that, ID will be there. The receiver will see what is the ID. Correct? If ID 0 means engine speed. For example, ID 1 may be engine torque. ID 3, sorry, ID 2 is in engine power. This is torque. Engine power. Who knows all the information? EMS, engine management system. Now, I wanted to connect now we are talking about brake, correct? Say our ABS, wheel speed, right? Vehicle speed, right? This will be given ID4, ID5, right? Then we are talking about steering control, SC. ID6 is steering angle, right? ID7 is steering torque. Okay, so if they are all connected by CAN bus, they are all connected by CAN bus. This is my CAN bus. You can see the all are parallelly connected. Now, if ID7 comes, correct, in the CAN bus, ID7 is available on the CAN bus. Correct? What is ID7? Is automatically known that it is steering torque. Who is going to send? This will be sent by steering controller only. Right? So, while designing the CAN bus hardware and also software, CAN control software, the engineers should sit together. Which engineer? Engine management group and ABS group and also steering control group. There will be separate group who develop hardware, software, all these things. They have to sit together. If they are going to use the CAN bus for transferring data between different ICs, they have to decide what should be the ID given for each message. Engine speed, what ID? Whether ID 0, 1, 2, 3, you can go up to 0 to 2047. That is possible because there are 11 bits available to identify message itself. Can this send as a packet? I told message. I'm going to show the next slide in a few slides. Correct? It is packed with the data. It packed with the ID, the message ID, and as a start bit, stop bit, and error correction. Instead of parity bit, it uses CRC, error correction method. Correct? Like that, it is very big. There are very long number of bits, binary bits are added apart from the data. Correct? So that means each CAN message should have an ID. Without ID, the data cannot be transmitted. That is a rule. Okay. Now, in CAN 2.0, they allowed 11 bits for message ID. So how many is possible? I said 2 power 11 messages are different messages are possible within the configuration. Because I am showing 3 ECU. They are going to. So each ECU can you have maybe 500, 600 different messages. Correct? But please note that the engine ECU doesn't generate that much. But I told you the CAN bus was started by this one Bosch for vehicle control, automotive. Now it is used for wherever automation is there, robot control, industrial plant control, or for example, your manufacturing, correct? Plant, assembly line in this one. You may have FMS, all these things. Made hundreds of robots, all these things. They are all connected by CAN bus. So each device may generate some 10 messages. If there are 20, I told you, in CAN bus up to 256 devices nodes like EMS, like ABS, like that, you can connect up to 256 devices in one bus, maximum allowed. So each device has 10 messages. How much are 2,500 messages, right? So each message has specific ID. The message ID, from that you will know that this is what the message. How do you know that it's engine speed data or steering angle data? By seeing ID number. So while designing this bus, right, you are going to generate for your vehicle, all 3 people should sit together, electronic engineer, software engineer, engine people, all this thing you have to sit and discuss what should be the ID given for each message. Once I decided, you cannot change just like that. That's it. Changing is not possible. So you have a very systematic approach you have to do. I already told you, when 2 messages, 2 devices want to send message, already CAN bus, I told you, any device can transmit any type, multi-master, right? Multi-master. When nobody is sending data, there's no data on the CAN bus, correct? So engine, you are applying brake. That means ABS will try to send data. Simultaneously, you are turning steering angle also. Steering controller. So steering controller will try to send steering angle. ABS will send the vehicle speed. All to the engine ECU. Now two people are trying to send the data. Correct? I told you, in your wire at a time only one message can go. Then two people simultaneously, because they are all electronic, they can send data at nanosecond without difference simultaneously. Then data will be corrupted. Correct? So then that is the how will you avoid that? You need an arbitration mechanism. If two people are sending two messages simultaneously, one fellow is sending steering angle, other fellow is sending brake control. Correct? Which message should go? But you know that each message has an ID. I say that already we given. Steering angle is given ID 6, and vehicle speed ABS is giving ID 4. Okay, both are coming simultaneously. Two ECUs are sending in the CAN wire. Not allowed. How do you know? In CAN bus, the message having lower ID number, message having lower ID, message ID have highest priority. In this case, what will happen? ABS speed, the steering controller should stop sending message. Both will put the message. First they send the not message, the data. First they send the ID, because the serial communication. First they send the ID. When ID is seen by other controller, both will see whose ID is lowest number. In this case, I said ABS ID is ID wheel speed is vehicle wheel speed is ID 4, which is lesser than ID steering angle ID 6. Automatically, the steering controller will stop sending data. It will allow the ABS to send the data. So you have to decide while designing the message IDs. While designing the system, as a software engineer and a hardware engineer, as a vehicle designer, you have to sit. So priority. Compared to engine or compared to steering, most important is brake. Somebody applying brake, the vehicle should stop. Steering also can take little later. Engine can stop, nothing wrong, but brake should be applied. So you design the priority message. The priority of the message depends on the message ID number. Message ID number. Lower the ID number in CAN bus, correct? Lower the ID number of the particular message, it has highest priority. That means the ID 0 has the highest priority. ID 0 has the highest priority. ID 2043 has the lowest priority. If you use all the messages, you can have up to 2048 messages, because you have 11 bit for identifying message. Value can vary from all the bits are 00 to all the bits 0001, 0 like that. You can go up to this one. Right? It is 1, 2, 0, 1, 2, 3, 2048. Right? That's how it works. Okay, but so the CAN originally CAN 2.0 had only 11 bit. That means 2048 different messages only possible. Suppose you have more than say 100 controllers or 200 controllers. You go to petrochemical industry, correct? Cracking column, petrol column. There may be 1,000 controllers, ECUs. Pressure, fluid, they are spread over 1 kilometer distance. Heating, cooling, correct? Cracking column, controlling many things. Chemical industry, sometimes you see 2,000, 4,000 electronic control unit, ECUs, controlling the plant, chemical plant. So they are using CAN bus, because CAN bus is a very secured bus, very good bus. In that case, how will you do that? Then they said that 11 bit is not sufficient. Increase number of bits to 29 bits identifier. 29 bit identifier means 2 power 29 different messages are possible. 0 to 2 power 29. Millions of messages are possible. You don't need that, but they have given that much. That means maybe around 5,000, 6,000 ECUs can be connected. Each ECU can send 100, 200 messages like that. Right? So that is what, but nobody uses. That is a provision available. Thinking that, because you cannot change the standard just like that. There's a big international committees that everybody's already made equipment. You cannot, there will be billions of ECUs already made. You can't throw it out. Right? So they decided this what this is. Okay, these were the different main difference between 2.0 and the 2.0 A and B. Okay, now we note this CAN bus protocol, how it works. A node, a device that initiates sending data is called a transmitter or master, bus master. Transmitter also called as a bus master, because while sending data, others should just listen only. Only when this fellow stops sending, other fellow can send his data, and if his data ID or message ID is highest priority, he can transmit. So there's no separate person to arbitration. In CAN bus, anybody can become a master, but you will become master provided your message ID is lower than other fellow who is trying to send simultaneously. One after another, no issue. When simultaneously two people want to send data, the ID decides. ID decided by during designing bus itself, by the design engineer, not by the controller. Okay. The receiver is called as a node that is not sending message called a receiver. Okay, transmit receiver. Message is assigned to static priority. This is what I was talking. Static priority means we can see the LIN bus, the other buses. When you go to other buses like LIN bus, all those things, the priority can be changed dynamically. While sending data, you can change the priority. In CAN bus, it is not allowed. Once the message ID decided, the controller or the ECU cannot change the priority. Message priority is assigned statically by giving ID number. That is designed by design engineer, not by the controller. Already you have decided that you are given the message. Okay. Transmitting node will remain as a transmitter until bus is idle or it supersedes another node. That's what arbitration. Highest priority message sending means other fellow has to wait. Okay. Otherwise, one more thing also will happen. But engine ECU is already start transmitting speed data. Okay. Now, ABS you applying brake. Correct? So, what will happen? Engine ECU, engine speed is ID number 8. ABS data is 3. Engine speed is already getting transmitted. You are transmitting 8 bytes of data. Correct? It will take some milliseconds. That time, if the ABS message comes, what will happen? The engine data ECU will stop sending message. It will be discarded, and the ABS data will become, because ID is higher priority. That data will be sent. That's what is mentioned here. CAN message can contain up to 8 bytes of data. Already told you. A message ID will describe data content used by receiving the data that determines the destination of network. The maximum speed is 1 megabits per second in CAN 2.0 on this one. For short distance, if there are two devices or CAN bus, this is the node 1. I told you node 1, node 2 is nothing but the device 1, device 2. Okay. And if you want to transmit at 1 megabits per second, the maximum distance is only 40 meters. The wire length can be only 40 meters. Okay. If you want to transfer longer this one, you can send up to 500 meters, provided you reduce the speed of transmit speed 125 kilobits, 1/8 of the speed. It can work. Okay. So here you can see that connecting two nodes. How you connect? So you see that this is node A, this is ABS, and this is engine management system. There are two nodes. Okay. These are nothing but software. This is called application is nothing but software layer. Correct? In engine, you see there's a software that is stored inside the ECU. Correct? This is microprocessor, microcontroller. I'm using 80C16 Intel microcontroller in the ABS ECU, and engine management I'm using another CPU, C167 CR, another microcontroller. Okay, and after that, this is then this is called CAN controller. You cannot control the microcontroller directly to the CAN bus. You need CAN controller IC and CAN transistor. Two ICs are needed. Already this RS2, what I said, you have the microprocessor, microcontroller. It sends data to the trans receiver, right? Which convert 0 to 5 volts into minus 12 volt to plus 12 volts, right? This is the RS-232 communication. Again, there's a trans receiver, there's a ECU. Here, the 5 volt is shifted to plus 12 volt, minus 12 volt. Again, this is received and again converted to 0 to 5 volt to the second ECU. This is transmitted, this is receiver. In case of CAN bus also, you need a CAN controller and also a trans receiver. Okay. Nowadays, this ECU, this is Intel microcontroller. I know 80166 is Intel microcontroller. It doesn't have CAN controller. Correct? CAN controller used for packing the data. Correct? Data coming from 8-byte data is coming from here. The data should be packed as a message packet. Then you have to add the identifier. Then you have to add a start bit, stop bit, CRC bit. I'm going to show in next slide. All these things will be done by this CAN controller. The CPU gives just data only. This data will be supplied to the CAN controller. Here, message is created. Who is creating? Message is created by CAN controller. Then it goes to CAN trans receiver. Here, it is 0 volts, 5 volt signal. This is converted into 1.25 volts to 3.75 volts. And that is what put as a CAN H and high in the CAN bus. It goes here. Again, here, this message comes and again it comes 0 to 5 volts, goes to CAN bus, CAN controller and receiver side. The CAN controller strips off the ID, then start bit, stop bit, error control, all this code, and then just get the data. Data is given to the ECU. So, if you want to use a CAN bus for your, if you are developing ECU or for your vehicle, for a brake control or something, you need a microcontroller which is going to do all the calculation, control signal generation. To transmit data, if you want to use a CAN controller, you need this. Okay. But there are, you can see that this microcontroller, Intel microcontroller doesn't have CAN controller. You have to buy separate IC, 81C9, 95 something is there. This CAN controller and on CAN, these are separate ICs. Apart from the micro, you need 3 ICs. But in case of C167 microcontroller, CAN bus is integrated. Inside the microcontroller itself, the CAN controller integrated. So only you need to buy the transistor IC only. So if you are designing CAN bus, you have to decide whether you want to have this ECU and this CAN controller, this one, or you can go and check the microcontroller specification. There are many microcontrollers which are built-in CAN controller. So you can reduce the cost. This is one IC, another is 2 ICs, 1 plus 1, 2. In this case, 1 plus 1 plus 1. You need 3 ICs. Correct? Space, cost, all these things will increase if I use this configuration. To understand, I am telling you what is inside. Okay. So this is it. You can see that this is called twisted pair wire. CAN bus is CAN cable is inside that you have twisted, which reduce the EMI noise. Okay. And the end of the wire, you cannot leave it open. You have to terminate 120 ohms. Both end of the wire, CAN bus controller, the end of the wire should be terminate 120 ohms. Is a compulsory standard. You cannot 100 ohm, 200, 1 kilo ohm. You have to use 120 ohm. We call terminator resistors. You cannot leave it open without this one, 2 wires end. Because you are tapping from the wire, no? The end you cannot leave it open, CAN bus. You have to put this. That's what I want to note down. That's a very important point. If it is not there, the CAN bus will not work properly.
So just one small doubt.
Yes.
Does it mean at the end, at the point where the device is connected to the CAN, even there at that point?
No, they are not needed.
Okay. Okay.
Tapping point not needed.
Okay.
End of this CAN wire.
Mm-hmm.
You cannot leave the wire blank.
Okay. Okay.
You have to connect with the 120 ohm resistor only. There are terminating resistors. Both end you have to do that. Because one of my students were doing this CAN bus controller some 6 years before MTech project. That fellow will come and say, "Sir, it's not working. My bus is not right." And he connected to ECU, developed something for autonomous vehicle. CAN bus. He designed his own CAN bus, all those things. It was not working. Then I found that he has not put the terminating resistor. So it won't work. Okay. Apart from that, I told you the CAN bus use what you call a differential bus. Please note down all these things. These are the expected in the exam. That's why I am systematically explaining. Right? Differential bus. What is a differential bus means? You see that the input given is a 0 volts or 5 volts. Right? This is single-ended bus. Single-ended connection input. Single-ended means there will be one ground wire, right, which we say G and D, which is nothing but 0 volts, and other one is a signal wire, in which only your signal is going between 0 and 5 volts. This is signal wire. Other one is a ground wire. Most of the time, that's what you say. So the voltage, this is called TTL level, 0 volts or 5 volts. Here you have your microcontroller, or mu P. It is sending data. I want to send to CAN bus. So it gives 0 to 5 volts. Right? 0 volts, 5 volts. That is signal. Other one is ground signal. Okay. This is called single-ended input. Now, if I transmit, single-ended input will always prone to noise, EMI noise. Instead of that, if I send differential voltage, which is called floating this one, you can see that this is given. Here, it gives two voltage. One is plus voltage, V plus and V minus. With reference to ground signal. This is my ground. Supply ground, 5 volt ground. With respect to that, one is called low signal, other one is called high signal. This is called differential output. If I use this is what CAN bus is using. In CAN bus, I'm going to see that one is called CAN H, other one is CAN L. Right? So it is not 0. What the voltage transmitted will be, next slide I will show you that it is going to be not 0 volts, plus 3.75 or plus 2.25 volts. Sorry, 1.25 volts. The CAN bus voltage never comes to this, between this wire will never have 0 volts. This is called differential bus. What is the advantage? It reduces EMI noise. EMI noise is reduced in CAN bus by using two techniques. One is twisted pair wire. Wires are twisted pair. Other one is using differential voltage for transmitting data. These two are used for reducing noise in CAN bus. Because why? In the vehicle, you have spark plug, most notorious place to generate EMI noise. Correct? 30,000 volts spark. Spark voltage can pick by even 20 volts, 30 volts. Wires are very close to spark plug. Petrol engine definitely you have. So that is why CAN bus, because Bosch was struggling before building the CAN bus with the RS222. There's a one bus called RS422 that uses a differential bus. It is similar to RS232 only. RS232 is a single-ended bus, right? It uses plus 12 and minus 12 volts for transmitting voltage with respect to ground. Then RS432 uses but here it is a single-ended only. But in this case, they were using RS432 use a differential bus. Because I don't want to go deeper with more electronics. We don't have time for that. Just understand. So the same thing was copied by Bosch also while they designed the CAN bus. So they are using differential bus, differential voltage and twisted pair reducer EMI noise. That's what I want to tell. I will go to next slide. Okay. The next thing is the CAN protocol. Use what you call ISO standard, Open System Architecture, OSI protocol, communication protocol. OSI communication protocol, 7-layer protocol they call it. Just for information only, there are different layers. One is called application layer, other one is called presentation layer, session layer, transport layer, network layer, data link layer, physical layer. The names you understand what it is. Already the definitions also given. So the physical layer is nothing but we already see that define the physical specification of the device network, including connectors, cable, electrical specification. We say plus to voltage varying plus 1.25 to 3.75, all these things, voltage, number of pins, CAN H, CAN I, all these things under the CAN controller IC, this IC, no? This IC, these wires, all these things are called as physical layer. The physically there's a wire, there's a resistor, terminal, there's a transducer IC, there's a CAN controller IC, there's a microcontroller. All these things are needed. They are called physical layer. Okay. That is called as lowest layer, physical layer. Above that, you have data link layer, which provides this one. So this is what the physical thing, IC, resistor, all those things. Remaining things are implemented as a software. Okay, these are implemented as a software. That much is sufficient. If you want, you can go and read more. Okay, I'm not going to explain all these things. These are the different layer. This talks about this one. This remaining data link. This is the top, bottom up. This is the level 7, right? Layer 7. You can see that application layer, right? Percentage. So here content creating fragments. So you have data. The data travels down. Finally, it is transmitted to the wires. That's what we are saying. 7 layer. Okay. Just know this. I'm not going to ask. Know the names. That is sufficient. There's 7 layers. Starting the application topmost layer. That is nothing but you are writing a program. Correct? ABS controller software, you are writing this one. Correct? Using your Python or C, C++. Correct? If the brake switch is pressed, correct? Then open this one, ABS controller. Or if the throttle is pressed, you are writing some program, no? Increase the fuel injection quantity, all this thing. That is called application layer. This is a program. There you are generating data, correct? That data has to be transmitted. So it goes to next layer, presentation layer. Right? Still it is data only. Then it goes to session layer. All these things has some small work it does. You can see that establishing, please see the presentation layer define the thing like data compression, encryption. Correct? Data cannot be sent directly. Sometimes you have to compress data to save the bandwidth. That is a communicate. Don't worry too much about it. I'm just saying, correct? So compress. You will not directly send data. Many times you have to compress data, remove unwanted data. All those things are done by presentation layer. Then session layer, this transport layer provides the transfer data between address and issue, error control, security, all those things. Correct? Then the network layer is routing. Finally, data link layer. This many of the layers will done automatically by the CAN controller. You don't worry. I told you this CAN controller takes care of all those things. The 7-layer protocol, no, the data coming from the application, this is from CPU or microcontroller, that is sent to the whole thing is done by the CAN controller IC. You need not worry, it is done automatically. From the CPU, send the data. I want to transmit data through CAN bus. All this thing is done and finally given to CAN transceiver IC. Which IC? This IC. Data is coming from here. It goes to CAN controller. Correct? CAN controller does all the operation, all the 6 layers. Then it sent to CAN transceiver. Then the CAN transceiver physical layer will send the data. That's what I want to say. You need not worry. What it does is there. For the sake of completeness, you can note down if you want. Okay. Okay. Same thing only I explained. This is what the standard, Internet ISO standard, which is nothing but a CAN bus standard. Okay. So application layer is, please see that everything is software only, except the physical layer. Correct? This is called the physical layer, the whole thing. The whole thing is physical layer. These are all software. Is implemented through software. All these things are done internally by the CAN controller itself. Please note that all these things, many of the things are done internally by CAN controller. Something you may have to do, something is done internally. When the data is received, this is the data, correct? Data is received from the controller. You may use a microcontroller. From here, it comes to here. Here, this operation is done. All these things are done. And finally, it comes here and transmitted to next device. Okay. Now, already to explain little more, I want to say what the CAN line driver, CAN controller and CAN line driver. There are two things. CAN controller, correct, is one which does all this work. When data is given, creating we are going to see, correct, creating start bit, creating stop bit, CRC code direction, all this, packing the messages, everything, all these things are done by this CAN controller. This CAN controller going to do it. Along with some software, you have to write some software also, right, in your application software. Okay. Then from there it comes to CAN transistor. What is its job? From here, the voltage here will be 0 volts or 5 volts only. Logic 0 means 0 volts. Logic 1 means it will be 5 volts. Your bit data will go like this. Already you know, correct? This is 1, this is 0, this is 1, 0, 0, 1, something like this. Right? This is one byte. This byte, when it comes to transceiver, it converts into CAN H, and this one is the voltage level. You can see here, and 1 point. So it sends simultaneously. 0 is sent as 1. This is sent as 2 voltage levels created that will be transmitted. So this is CAN H. This voltage will be transferred to CAN L. You can see that the difference voltage 2 volts. Correct? Normally it will be 0 volts, ideal condition. When it wants to transmit, it will send the differential voltage. This reduces this one. And another thing also you will talk, one is called a recessive, other one is dominant. Correct? If your data value is 0, it is called a dominant. If data value is 5 volts, it is called recessive. Generally bigger is called dominant. No, if there are 2 person, one fellow is strong, you say he is dominant. Weaker, but in case of CAN bus, 0 volts is lesser, 5 volts is greater, but 0 volts is called as a dominant voltage level. 5 volt is called as a recessive voltage level. We will see why it is. This is used for arbitration. Arbitration requires this. That's why we are going to see. Okay. So what is inside the CAN transceiver IC? I told you this is CAN transceiver IC internal. I am not going to ask you to draw this. And just for your understanding will. Correct? You can see you are going to give here you have your CAN transceiver, CAN controller. This is connected to your ECU. Or the whole thing can be in one ECU itself. I told you there are some microcontroller built-in CAN controller. Already I showed you, correct? So now they are going to connect it like this. Okay. Now here it will be 0 volts or plus 5 volts only data between this one. But here it comes, you can see here 3.75 volts, CAN high, CAN low is 1.25 volts. Okay. Now you can see here. Now if I want to transmit the bit equal to 0, correct? When I want to transmit a bit equal, this is data, correct? I am trying to transmit 4 bits. One after, because serial coming one after like RS232, correct? First bit is 0. What will happen? CAN high, this wire will become 3.75 volts. This wire will become 1.25 volts. Correct? During this is 1 bit duration. But this amount of time, maybe 1 millisecond, for example, CAN low will become 1.25 volts. CAN high will become 3.75 volts. The difference is more than 2 volts. Minimum difference is needed is 2 volts. Correct? You can see that it is more than 2 volts. Okay. Now, but next bit is high. What the data I wanted microcontroller send this bit. So what will happen? Both the bus will become 2.5 volts. CAN high, both will become 2.5 volts, middle level, not 0. Please see that CAN bus never comes to 0 volts. This is 0 volts. It always remains in 2.5 or 3 like this. So next bit is again 0. That means immediately this is next bit. You can see that both this is 3.75 volts. This is this one. So this is called a dominant. When the voltage is 2.5 volts, that is called recessive. This is how the CAN bus works. So by all, it always will be 2.5 volts going up and down. It is transmitting the data. Okay. CAN protocol specify rules for implementing physical layer. Already we talked about it. In CAN, data is called as frames. Another thing, message and also called another thing called frames are there. Okay. There are 4 different types of frames. One is called data frame, remote frame, error frame, overload frames. I am not going to discuss these things. If you want to know about it, it's a separate area we need to discuss a lot. I will just discuss about data frame alone. Okay. In data frame only you will send the data. Okay. If some error happens, receive data, then error frame will be generated by the receiver. Okay. Overload frame, all these things for error correction, something like this. I am not going to discuss about it. I will discuss about only data frame. Okay. Note that this is very, very important. In the exam also you are expected to draw this. Not this one, but at least approximately you have to identify. So for example, if you want to send a CAN message, it is called CAN message frame. Correct technical name is called message frame. Okay. Or data frame. We are talking about data frame. You can see here, the whole thing is called as, now you can see that there are so many things are mentioned. First, this is called as 1 bit duration. Right? This is 1 bit is SOF. SOF is nothing but start of frame. You know that in RS-23 we talked about start bit. So SOF is called as, you can consider similar to start bit. Right? Start of frame. How many bits you use? 1 bit. The length of the start frame or start frame is known as start bit. 1 bit. Next one is 11 bits are there. This is 11 bit period. The 11 bits used for message identification. Identify is nothing but message identification. Message, this is called message ID. They are called, right, identifier. That's what. How many bits are there? 11 bits. That means if I want to draw the figure, this is very big, right? So already it is shown here, there are 11 bits. I could not draw, right? There are 11 bits. This is 1 bit. We could not draw proportionately. Please see that this is 1 bit means this should be very big, but you have to imagine that within this there are 11 bits, 11 bit duration. If this is 1 millisecond, what is this? 11 millisecond. There are 11 bits, right? The bit value can vary from 000 message ID identified to 11. There are 11 bits, 1111, right? So there are two. This number will vary between this 00001, then 0001, 10 like this binary number, correct? So 2048 different message can be sent. So next bit is called RTR bit, right? What is RTR bit? Remote transmission request. Okay, it is a 1 bit. RTR is a 1 bit. Next thing is what we call reserve bit. In CAN 2.0, this was not used. They kept it for future, correct? Because once you define, you cannot go on change, because ISO means for all 138 countries, the representatives should come, they discuss, it will go years together, discuss. This was not desired one-day business. Companies should agree, the ISO committee should agree, countries should come, all those things. They're a big group. They'll be discussing for months together, many meetings. So the future something they were reserved, correct? Reserved for the 2 bits, reserve bits. Okay. After that, DLC, data length code, DLC. What is data length? I told you how many bytes of data you're going to send. This is what your data. This is your data. This is data length bit. How many bits? There are 4 bits. Correct? What are the values can have? 4 bit mean binary 00, 001, 0010, 0011, 0100. Like this, all bits can do this one. This is not a decimal 0, 1, 2. This is binary. Correct? 4 bits combination. this is 3, this is nothing but 15. Totally 16 states. Right? Now, I told you how many bytes you can transmit in CAN 2.0? 8 bytes. So, you need 8 is nothing but 0, 1, 1 is 7, 1, 0, 0 is 8. So you need 4 bits. That is why the DLC, you say how many bytes you are transmitting in this message ID. The message ID I say message ID equal to 0. Okay. And you want to transmit engine speed alone. Correct? How many bytes will be the engine speed? What is the engine speed can vary in your vehicle?
0 to 100.
Engine speed.
Oh, engine speed. Okay.
It will be 0 to 10,000 RPM.
10,000.
Yeah, 0 to 10,000. Correct? That is what possible engine speed. Now, if you want to transfer, how many bytes you need? If you have 8 bits, 1 byte, you can represent to 255 only. Correct? If you have 16 bits, how much you can say?
65535.
535.
65535.
535. Correct? That's for 0 this one. That means you need how many bytes? If you use 1 byte, you can refer only up to 0 to 255 RPM only. So minimum you need 2 bytes. 2 bytes means 16 bits. So that means your engine speed will be 2 bytes. Engine speed ID you are assigned equal to 0. The data length equal to 2 bytes. Now in this ID you can pack up to 8 bytes. But you have decided to use this ID only for engine speed. Then how many bytes you are going to transmit?
2 bytes.
2 bytes. So in that case, what will data length, DLC, what will say? 0, 0, 1, 0. Correct? Then you put the engine speed data as a 2 bytes. Remaining byte you don't send. So how many, the data length says how many bytes you are going to transmit in this message. Okay? For example, another way I will say that engine ECU, engine speed, correct? Engine torque, engine power. Speed already you know you need 2 bytes, correct? What is the engine torque can be generally? Generally you say Newton meter.
200 Newton meter.
100 Newton meter, correct? 100 Newton meter, you need 7 bits are sufficient. So generally minimum is 1 byte. To engine torque 0 to 100, that means 1 byte is sufficient. Correct? Engine power. Again, how much? Engine power.
It depends, sir. Basically, 100 PS per liter is the 100 PS, 90 to 100 PS per liter.
No. We are talking SUV, some sports car, 300.
So it can go to up to maybe around, you can say,
200, 300,
200,
400.
yes,
Correct?
200.
So that
yes.
means that exceeds 255. Correct? Engine power exceeds because torque will not exceed more than, torque also can go. Correct? So torque also can go up to 150 Newton meter, 200 Newton meter, 250, maybe 300 Newton meter race car. So in that case, we can need 2 bytes. For example, I'm saying 2 bytes. Correct? The power also 2 bytes because you are exceeding beyond the 255. So totally how many bytes? I want to pack all this thing as a one ID because who is going to send? Engine management. So I will add 2 bytes, 2 bytes, 2 bytes. So that means I can consider like a compartment. Correct? This is byte 0. This is byte 1. 0, I say B1, B2, B3, B4, B5. These 2 bytes are used for speed. These 2 means for torque. These 2 are power. I want all these things sent as one message. I can pack. Then I will say the message ID. ID, this is equal to 0. Message ID 0. Okay. Now, this message, the message ID will go here. 0. What is the length you need now? How many bytes you are going to transmit? 6. You'll say 6, then you pack this data here. You got it? So in your message, you can send 1 byte or maximum 8 bytes. You can say data like maximum. How many bytes you are transmitting? Receiver should know. This is message ID. But how many bytes data is there? How will the receiver know? He will read this DLC. Whether 1, 2, 3, 4, 5, 6, 7, 8. You can give anything 1 to 8 only. If you say 8 means 8 bytes of data is there. 1 means only 1 byte data, remaining don't need not read it. Okay. Then next thing is this is data. This is DLC. Next is 15 bits are called CRC, cyclic redundancy code. Redundancy code. CRC. You can see cyclic redundancy code. Here, cyclic redundancy code is similar to parity. Parity bit. In RS-232, similar to the cyclic redundancy for it is error checking and error correction that are possible. Cyclic redundancy code for detecting error in the received data. Which data? The data what you are sending. Correct? This is data you want to transmit. You see how many things you are adding. In the RS-232, what we did? 1 start bit. Correct? Then 8-bit data. Then 2 stop bits, 1 parity bit. Right? For 1 byte of data. But in this case, you can transmit up to 64 bits maximum. Right? 8 bit is 64 bits. But you can see that what other things are added. You see all other things. I want to complete this today. Just 5 more minutes. I'll just close it. Then tomorrow, Monday, we can continue. Okay. So CRC for error correction. Then you have CRC delimiter, 1 bit. Then acknowledgement slot. Another acknowledgement slot also is that is 1 bit. Then ACK delimiter. Then finally end of message, end of frame. End of frame, you can see here there are 7 bits. It is like a stop bit. Okay. Then you have 3-bit INT. Right? INT, I think it is shown in next. I just forgot. I'll tell you next. What I want to say is, because in the exam you may be asked to draw the frame of CAN message and tell what are different fields. These are called fields. Correct? So field 1, field name, number of bits, and this one just because this is what you have to understand. I'm not going to describe, but at least you should know. Draw the CAN frame on this one. Okay. Now, what is the efficiency? Transmission efficiency here. Anybody can say?
Sir, 66% you are told, na?
So which one? That is
No.
for RS-232.
For this, it will be number of bytes we are basically sending into 8.
Maximum
divided
how
by
many bytes you can send?
8.
8
8.
bytes.
That means 64 bits divided by total bits.
Total bits.
You add all these things. This is 64. 1 plus
So
2, 12.
only 25%.
Huh?
Only 25%.
Around 25% only or 30% only will be there. Because this is 12, 15, 19, 19 plus 64 plus 10.
It is
10
around
plus 15.
60%, sir.
Huh?
It's coming around 60%.
Okay, coming
Total
around
number of bits is
60%.
108. And
Yeah, correct.
out of which
So-
64 are being transmitted.
Yeah.
as data.
So you see that here the efficiency is this one, but you are sending more data in one packet. Correct? If you pack your message with 8 bytes, that much efficiency. Suppose if you send only one byte 8 in your message frame, you send only 1 byte engine speed alone or 2 bytes. what will happen? The efficiency will come down. Correct? Efficiency will come down. Just that's it. Okay. So I will stop with this slide. Other than CAN 2.0, only one difference is you can see that here they are using totally 11 bit plus 18, 29 bits identifier. That is main difference. Main difference is the identifier length is larger. So that means 2 power 29 messages can be created. The CAN 2.0 only 2 power 11 messages. That is 2048 messages. Right? In this case, 2 power 29 millions of messages you can create. That is one debate. Otherwise, everything is same. See, message in this one also 29 bit for identifier. That means 2 power 29 messages can be created. If you have hundreds of ECUs, each ECU is generating 10, 20, 30 or 50 messages. It can happen. Please note that don't think petrochemical industry, chemical industry can happen. There are many devices connected. They have to talk with each other to CAN bus. Other than nothing more, the other thing, everything is same. I will stop here. We will meet on Monday. Okay. Have a nice weekend. Thank you. Give attendance a message.
Sure, sir. Okay.
Any questions?
Thank you, sir.
Thank you, sir.
Okay.
Sir,
Take care.
what
Yeah.
are the portion left now?
Pardon?
What are the portion left now after this path planning you told me, sir? After this?
No. Then LIN bus is there.
Okay.
After that, wireless communication.
Oh, okay.
Wireless communication will take 4 hours. Correct? LIN bus, CAN bus will take another 2 hours. Monday I will complete. Next week I will complete by next week wireless communication, Bluetooth, Wi-Fi, wireless communication, vehicle to vehicle communication will complete next week. Last week we will have this one, the path planning.
Okay, sir. Thank you, sir. Thank you so much.
Thank you. Give a chat message as attendance without saying. Shall I close? Message is given, chat message.
Just a minute, sir. Typing it. Yes, sir. We can close.
Others?
Yes, sir. Okay, sir.
Okay. Thank you.
Thank you, sir.
I am
Thank you, sir.
closing.
Thank you, sir.
Thank you, sir.
Okay. Have a nice weekend. Take care.
You too, sir. Thank you.
Yeah.